Here we're looking at practice problem 7.16. The initial conditions shown here. So we have a step response, VI, which is 9 UT. That means it's 0 until t equals 0, and then it is a step function up to 9 volts. So that looks like this. So V is equal to 0, and it steps up to 9 volts right here at t equals 0. So the question is, how do we analyze the circuit? So first of all, we look at the op amp, and we see that it's connected on the plus side to V sub I. That means the same voltage here on the minus side, or this point is V sub I. Now we can get, we know what VI is. Again, that's the 9 UT. So we can get the current through this resistor. We'll call that I1. Because if we go from around here, we get a KVL plus I1R1, jump from VI to 0 plus VI is equal to 0. So I1 then is just equal to minus VI over R1. Now, this current is the same that flows through RF because there's no current that flows into the minus. So we can then write over here, if we call this point V sub A, we can take the voltage difference between VI and VA, VI minus VA is just equal to the voltage drop across the resistor I1RF. We're rewriting VA is equal to VI minus I1, which is minus VI over R1 times RF. Or we get VA is equal to VI times 1 plus RF over R1. Now, as we note, RF is 40, R1 is 20K, so this is 2, the ratio, so it's just VI times 3. That's what VA is. So we've now found VA. It's a known quantity. Now we just have to set up our differential equations. Okay, so we know what the voltage is here. All right, and again, this is going to be a step function. So initially, this capacitor is going to have no voltage across it when there's before t equals 0. So it's going to be continuous. The currents are not continuous, but the voltage is. All right, so if we take a look here, let's take a look at the current flowing this direction. We'll call this IC, and it's flowing through the capacitor. So if we start here from ground, we get a minus VA plus ICRC plus VC, which is also equal to V0, all right, is equal to 0. Because we're back at ground. So VA is equal to voltage across the capacitor plus, now IC is just C dVC dt Okay, multiply that times R. I wrote RC, it should be R3. Okay. Now, all we need to do is put in 3VI here. 3VI is equal to VC plus, now what's RC? R3 is 10 kiloohms, just like R1 or R2 is. So it's 10K time, and the capacitance is 2 microfarads. That's 2 times 10 to the minus 6 dV dt. Let me slide this over just a tiny bit and up just a tiny bit. So 3VI is equal to VC. 10K is 10 to the 4th. This is 10 to the minus 2. 10 to the minus 6, so 10 to the 4. This is 2 times 10 to the minus 2 dV dt. Or it's 0.02. And 1 over that is 50. Well, we know the solution then is, on this side, this is 3 times 9, or 27 times u of t. Okay, that's equal to VC plus 0.02 dV dt. Now bringing this over here, since the voltage starts at 0, we know that it's got to start off that way. So VC, which is equal to V0 then, is just equal to this 27 u of t times 1 minus e to the minus 50 t. All right, so that's starts out at 0. So that's how you solve practice problem 7.16.